Hello, my name is Mark Budnick. Today, I'm going to be talking about some of our hands-on learning embedded systems classes at Valparaiso University. First, I'd like to provide a brief background about myself to put my presentation in context. I'm a 15-year veteran of the semiconductor and embedded systems industry. A majority of my career was in the field of applications engineering and management. This gave me a unique opportunity to see how engineers work on a day-by-day basis. In 2001, I became the director of motor control for Hitachi Semiconductor. It became my responsibility to train not only my embedded systems engineers, but also my customers' engineers. It was at that time that I realized my true vocation, and in 2006 I returned to academia and became an assistant professor at Valparaiso University. However, if I was going to be a professor, I was going to do it my way. I did not want my classrooms to look like this. Instead, I wanted my classrooms and laboratories to look more like my daughter's elementary school. Students fully engaged in the tasks at hand, actively learning and exploring the world around them. To that end, we provide our students in our embedded systems classes with a host of resources and tools for hands-on learning. 3 such classes are based upon the Texas Instruments MSP 430 FR6989 Launchpad. In addition, students have parts kits, shown here is one from Digilent, that include breadboards, jumper wires, LEDs and switches, and a host of sensors. Additionally, we are frequent shoppers at Adafruit and use them as our distributor for a variety of other components such as motors, keypads, and other fun toys. Finally, each embedded systems student gets an OWI robotic arm for use in their class project. With this wealth of tools, students are properly armed for hands-on learning. Here's one of our design studios for our embedded systems classes. We have 3 such studios that seat between 24 and 32 students each. At each station, students have a computer, oscilloscope, power supply, function generator, and multimeter. This mixed-mode classroom allows professors to move seamlessly between the traditional lectures and hands-on learning activities. My classes in these rooms typically begin with a 3 to 5 minute lecture introducing the topic at hand, and then moving straight into a hands-on learning activity. During their hands-on learning activities, students work their way through self-paced study guides that teach them the fundamentals of embedded systems engineering. The self-paced study guides are written in a lighthearted fashion and incorporate side comments like, "Yay!" or "Congratulations, you're awesome!" when students reach milestones. While students are working on their hands-on activities, professors and lab assistants are actively working with the students with a process we call teaching by walking around. On the left, you see a typical handout students will get for one of these hands-on activities. As students work their way through the handout step by step, they occasionally have to pause and get a sign-off after answering a few brief questions. This allows the professors to keep pace with the students and also talk to each student or student team 4 or 5 times every day. On the right, we show a typical example of a daily homework assignment that students must complete before the next class. With the hands-on activities in class and their daily homework assignments, students will be working with their embedded systems equipment 3, 4, 5, 6, or more times a week. We have bundled our embedded systems outputting lectures, hands-on activities, and some of our homework assignments into an online class that is offered through Udemy. For $20, this online class, or MOOC, has become our course textbook. The MOOC was rolled out to the public in October of 2015 and now has almost 1,200 paid students enrolled from 68 different countries. For our local Valparaiso University students, the short videos provide an excellent opportunity for them to go back and review any basic concepts they may have missed from class. When questions come up, either from the Valparaiso University students or the MOOC students, they can be posted directly to the appropriate lecture. In each lecture, students can also see the previous questions that have been raised by other students, as well as my responses to the questions. We have found the Udemy platform to be a very highly interactive tool that provides an excellent support for our students and their hands-on learning activities. Additionally, students can use the self-assessments at the end of each section of the online materials to understand where they may need additional review. Over the past 5 years, our students have very much enjoyed this hands-on approach to the embedded systems engineering. You see here that 92% of the students either greatly preferred or preferred the hands-on class to traditional lectures. Student self-assessments, however, should not be used exclusively to determine if a class was successful. Shown here is a final exam question from the previous semester. On their final exams, nearly 90% of the students in our Embedded Microcontroller 1 class have historically been able to complete programs of this complexity correctly. In summary, our department has wholly embraced hands-on learning in our embedded systems classes. We We get our students working with their hands on their very first day of class, and we believe the hands-on classes and assignments provide the students with the best opportunity to get the most out of their embedded systems experience. Thank you for listening.